We've talked a lot about angles dealing in circles. Man, we've talked a lot about them, okay? We've talked about central angles. We've talked about inscribed angles. We've talked about angles anywhere on the interior of our circle. Here we're talking about angles on the exterior of our circle. Notice how this angle right here is created by two secants, but it could be created by a secant, it could be created by tangents, doesn't matter what it is. That angle right there, that angle on the exterior is going to be half the difference of the two arcs that it creates on our circle. It's half the difference of the two arcs that it creates on our circle. That's our fact of the day. Let's use it. Here we want to find E. There is E, and we know that E, the measure of angle E, is going to have to be half the difference of the two arcs that it creates. 49 minus 13. What's 49 minus 13? It's 36. Half of 36 must mean the measure of angle E is 18 degrees. It's half the difference of the two arcs that it creates. We want to find the measure of angle Q. There's angle Q right there. Okay, we know the measure of angle Q is going to be half the two arcs, half of the difference of the two arcs that it creates. Now, it creates this arc that's 110 degrees, and it creates this arc, which is the rest of the circle. Notice it's formed by two tangents, and so P is separating this arc with the rest. R is separating the arc with the rest of the circle. So if this is 110 degrees, the rest of the circle would have to be 250 degrees. It's 250 plus 110 add to give us our entire circle, 360 degrees. Well, I know the measure of angle Q is going to be half the difference of the two arcs that it creates. Uh, 250 minus 110 is 140. Half of 140, 70 degrees. The measure of angle Q must be 70 degrees. We also want to find the measure of angle T. Okay, well this one, they're just trying to make us a little bit more confused. This is 68. This is 154. Well, if we subtract those from 360, we can find that other arc. Looks like a job for the calculator. 360 minus 154 minus 68, we get 138 degrees. Well, now I know if I want to find the measure of angle T, that exterior angle is going to be equal to half the difference of the two arcs that it creates. So we just slap that in there. Half of 70 must be 35 degrees. The measure of angle T is 35 degrees. It's that simple. It's that simple. Finally, got some application. We're already there, okay? Just got that one fact of the day here. It says a lunar eclipse covers an arc of the Earth in the moon's shadow. If observers in the 168 degree arc experience a full moon or partial eclipse of the moon, solve for x. X is that little angle right there. Well, we know, even though it's tangent to the moon's kind of irrelevant. It's just part of the problem. The observers are in space. They're looking on the other side of the moon. They're trying. Anyways, all we need to do is find x. This is that situation where both lines are tangent to our circle that's relevant to us. 168 degrees. If we subtract that from 360, we know that this arc would be 192 degrees, and I know that my angle that creates this is going to be half the difference in my arcs. 192 minus 168 is 24. Half of 24, x must be 12 degrees.